Hello. So today I'll be talking about Newton's laws of motion. While most people know what Newton's laws say, many people do not know what they mean, or simply do not believe what they mean. Newton's laws of motion. First law of motion, law of inertia. An object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by a balanced force. Inertia is the tendency of an object to resist changes in its velocity whenever in motion or motionless. These functions will not move unless acted on by unbalanced force. Once, once the airborne unless acted by an unbalanced force, gravity and air fluid friction. It would never stop unless um, acted upon by an unbalanced force. This golf ball would sit on the tee forever. Why then do we observe everyday objects in the motion slowing down and becoming motionless, seemingly without an outside force? It's a force we sometimes cannot see. Friction. Objects on Earth, unlike the frictionless space the moon travels through, are under the influence of friction. That's the unbalanced force that acts on an object in motion. Friction. There are four main types of friction: sliding friction, ice skating, rolling friction, bowling, fluid friction, air or liquid, air or water resistance, static friction, inertial friction when moving an object. Slide the book across the table and watch the slide to a rest position. The book comes to a rest because of the presence of a force, the force being the force of friction, which brings the book to a rest position. In the absence of a force of friction, the book would continue in motion with the same speed and direction forever, or at least to the end of the tabletop. Newton's first law and you. Don't let this be you. Wear seatbelts, because on inertia, objects, including you, resist changes into their motion. When car goes 80 km/h is stopped by the brick wall. But your body keeps moving at 80 km/h. Second law, F equals mxa. The net force of an object is equal to the product of its mass and acceleration, or F equals ma. When mass is in kilograms and acceleration is in m/s/s. The unit of force is in newtons n. 1 Newton is equal to the force required to accelerate 1 kilogram of mass at 1 meter/second/second. How much force is needed to accelerate of 1,400 kilogram car 2 meters per second/per second. Write the formula. F equals mxa. fill in given numbers and units. F equals 1,400 kg times 2 per second slash second. Solve for the unknown 2,800 kg meters slash second or 2,000 ATM. 2,800 and Newton's second law provides that different masses accelerate to the Earth at the same rate, but with different forces. We know that objects with different masses accelerate to the ground at the same time. However, because of the second law, we know that they don't hit the ground with the same force. Force is the push or pull that causes a change of the motion or an object. Gravity, force between the objects. Static electricity, force of electrons. Magnetism, force of the field. Sorry if I say it wrong. Friction, force opposing motion. Third law. For every action, there is equal and opposite reaction. According to Newton, whenever objects A and B interact with each other, they exert forces upon each other. When you sit in your chair, your body exerts a downward force on the chair, and the chair exerts an upward force on your body. There are two forces resulting from the interaction: a force on a chair and a force on your body. These two forces are called action and reaction forces. Newton's third law in nature. Consider the propulsion of a fish through the water. A fish uses its fins to push water backwards. In turn, the water reacts by pushing the fish forwards, propelling the fish through the water. The size of the force on the water equals the size of the force on the fish. The direction of the force on the water backwards is opposite the direction of the force on the fish forwards. Third law. Flying gracefully through the air, birds depends on Newton's third law of motion. As the birds push down on the air with the wings, the air pushes their wings up and gives them lift. Considering the flying motion of birds. A bird flies by use of its wings. The wings of a bird push air downwards. In turn, the air reacts by pushing the bird upwards. The size of the force on the earth equals the size of the force on the bird. The direction of the force on the air downwards is the opposite the direction of the force on the birds upwards. Action-reaction force pairs make it possible for the birds to fly. Other examples of Newton's third law. The baseball forces the bat to the left in action. The bat forces the ball to the right. The reaction. Consider the motion of a car on the way to school. A car is equal with wheels which spin backwards as the wheels spin backwards. They grip the road and push the road backwards. The reaction of a rocket is an application of the third law of motion. Various fuels are burned in the engine producing hot gases. The hot gases push against the inside tube of the rocket and escape out of the bottom of the tube. As the gases move downward, the rocket moves in the opposite direction. That's it. I cannot upload it to YouTube. So I'm just gonna have to like send this video just to you only. Just that.